The last video on angles looked at circles and the angles in circles. This will be looking at the same thing, but not the angles. It will be looking at right angled triangles in each of the three situations that you met in the previous video. There was an angle in a semicircle being a right angle. There was a tangent, a line that meets the circle at a single point, and the radius drawn out to that point of contact, making a right angle, and a chord halved by a diameter at 90 degrees. So a right angle triangle here is quite obvious. In the middle case, if you draw in a line from the centre of the circle joining to some point on the tangent with the radius here, it forms a right angle triangle. And in the case of the chord here being half by diameter, if you draw in a radius, you can form a right angle triangle. Now that means Pythagoras can be used, or trigonometry. There have been previous videos on Pythagoras and previous videos on trigonometry. So I'm not going to use any trigonometry here. I'm not going to deal with the case on the left where it's a right angle triangle from the semicircle, because it's quite obvious how trigonometry and Pythagoras works there. So it's the middle case and the right hand case. The right angle triangles here, mainly the one on the right. That's where most questions come up involving Pythagoras with circles. So here's the one on the right. The diameter halves the chord at 90 degrees. If you draw in a radius, you can form a right angle triangle using half the chord length. The radius is a hypotenuse, and this distance d is the distance the chord is from the centre. So that's from the chord to the centre is that distance d. And we're going to use Pythagoras on it. So here's an example. The idea is this is an arched bridge, and it's an arc of a circle. So it's formed using the arc of a circle, and the radius of the circle is 25 metres. So that's the 25 here. And the span of the bridge, that's its width, is 30 metres. So its width is 30. That's the blue line here. Is 30 metres. And it wants the height of the bridge, this part. Now, if we go back to that previous diagram, we've got this right angle triangle, but there's an extra bit to it, and it's this. This is what's commonly come up in the questions, it is in the one you just saw. This gap here, this missing part, is a full radius minus this distance d. So if you're using the right angle triangle and you work d out using the radius and a half chord length, once you get d, if you do the radius minus that d, that gives you the gap there. Now that's what's happening in this bridge example. If we use a right angle triangle where that's half the chord length, half the blue chord, because that blue line was a chord, it's half that 30, it's 15. The radius is 25, there it is there, 25 is the radius. That distance d, that's the distance the chord is from the centre. This distance we're after h is a radius minus d. So you work out d with Pythagoras, it's straightforward Pythagoras. It's a short side, so d squared equals 25 squared minus 15 squared, and follow it through. D is 20. Now of course that isn't usually a round answer like that. Usually it'll be rounded to so many decimal places. I've kept the questions to have no rounding in it, just to keep it nice and simple. So d is 20. The radius was 25, so from the centre all the way out to the circumference of the circle was 25, and d is 20. So this gap h is the radius 25 minus that distance d. So the height's 5 metres. So it's using this gap here, it's a full radius out, take away d and you get that gap. So that's a typical question involving the chord and the diameter using Pythagoras, but then with a little twist to it, like finding h once you've got d. Here's another example. It's doing the same thing. This is a railway tunnel. It's circular. It's got a railway track through it, so there's a bed there, and from A to B is basically the chord of a circle. So rail tunnel, radius 5, AB, which is a chord of the circle, is the ground with the track bed 6 metres wide. That's actually the size of the chord from A to B is 6 metres. So there it is there. So what's happening is it's 5 metre radius. The full length of AB was 6 metres, that was the track bed. Half that chord is 3. That distance down to the track bed, D, can be found using Pythagoras. D squared is 5 squared minus 3 squared, because it's a short side you're using. It works out exactly at 4. Won't usually be an exact answer. So D is now 4. What's the height of the tunnel it's saying? Well, this time it's that 4 plus an extra radius distance on the top. So the full height of the tunnel is D plus that 5. So the height of the tunnel is that D plus that 5. So there it is. It's 5 and 4 is 9. The height's 9 metres. So there's variations on these questions. This is now one involving the second case where you had a tangent and a radius drawn out to the point of contact, making a right angle. So if you had some point on the tangent, so you'd have to be told where that point is. The length of tangent involved from point P out to the point of contact of called L. That's just the length of the tangent from this point to the circle. From this point to the centre consists of 2 parts. It's got a distance from the point to where it just meets the circle, call that distance D, and it's got a radius. So the full distance of point P from the centre is R plus D. So P is R plus D away from the centre. So this hypotenuse is R plus D. Sometimes it'll be after D. That's the shortest distance from point P to the circle. So if you went any other way, it'd be longer. So going shortest distance to the circle is D. Shortest distance from point P to the centre is D plus a radius, D plus R. So it makes up a right angled triangle. There's a radius, there's a piece of the tangent from point P to the point of contact, and there's a hypotenuse which has got distance between point P and the centre, and that consists of distance D, shortest distance from point P to the circle, and a radius. So find the shortest distance of point P from the circle. What that means is find D. You have to get D. First you have to go is get R plus D from the Pythagoras' theorem. So, oops, there we go. What we've got is, that was 15 centimetres. This is a radius 8. This part's 8, a radius. And this part's what we're to find out, D, shortest distance from point P to the circle. So, there was a radius, 8. It told us that distance was 15. We formed a triangle, 15 by 8. You can work out the hypotenuse. Hypotenuse squared is 8 squared plus 15 squared. So the hypotenuse is 17. Well, this part of it's 8. So the remaining bit is 17 less that 8. So that makes the distance D 9 centimetres. So it is Pythagoras' theorem, but it's got a little twist to it. That the hypotenuse is the full distance here. That's a radius, so you can work out what D is. And D is the shortest distance from the point P here to the circle. Now, the worksheet, if you click the link in the description, you can get the worksheet. Most of the questions are using chords, because that's the commonest kind of question. Sometimes it's like the height of the tunnel you're working out. Sometimes you're told the height. So you have to work out the width of the chord here. Remember, when you use Pythagoras, you're getting half a chord. And there'll be the answers with that. So, plenty on that kind of question, just variations on it. And then some on the tangent and the radius drawn to the point of contact. So, sometimes it gives you the radius and the distance of the point from the circle, working out a length of the tangent. Or it could be telling you the length of the tangent, you have to work out the distance from the point to the circle. I'll have the answers with it. So you get 16 questions. So if you click the link in the description, there's a worksheet, 16 questions, and I'll have the answers. And from the same link, you'll get a set of notes. So this is this type of question we just looked at, but it's got notes on all previous stuff. So that's all on angles and quadrilaterals and circles. Working out angles, working out missing sides and so on. So this is applying Pythagoras. Hope you found the video useful. Thank you.